Today we're going to continue our study of imaginary numbers. And in doing so, we are actually going to go back and revisit solving quadratics by taking square roots. So if you recall, when we solve our quadratics by taking square roots, if we had something like x squared equals negative 25, we would have to take the square root of both sides in order to find our answer because we want to undo that power of 2. If we take the square root of x squared, we get x. Anytime you're taking the square root in order to find your variable, you want to put your plus or minus out in front of your answer. And then as we learned yesterday, anytime you go to take the square root of a negative, this is going to be an imaginary number. 25 is a perfect square, so I know that the square root of 25 is 5. And since I have a negative underneath my square root, then I'm going to have an imaginary number as my answer. So plus or minus 5i. If I started off with something like 5x squared equals negative 10, the only variable I have is one that's being squared, so I'm going to go ahead and isolate it, dividing both sides by 5. My 5's will cancel. X squared equals negative 10 divided by 5 will give me a negative 2. And again, we want to solve by taking square roots, so we need to take the square root of both sides, giving us x here, plus or minus in front of my answer. And then again, I have a negative here, so I'm going to have an I in my answer. 2 is not a perfect square, and it's not big enough to break down. So your answer for this is going to just be I square root of 2. I don't want you to punch that in your calculator, the square root of 2, and find the decimal value for that. We want to have exact values. So we're going to have radicals and imaginary numbers as our answers today. Let's look at one that's a little more complicated. 7x squared minus 9 equals negative 52. So we're solving by taking square roots. The only variable I have here is this x squared, so I want to first just get this all by itself. I'm going to do that by adding 9 to both sides. My 9's will cancel. I'm left with 7x squared equals negative 43. Divide both sides by 7. Cancels off the 7's, so I'm left with an x squared over here. Now 43 is not divisible by 7. So we're just going to leave this as a fraction for a minute, negative 43 over 7. So anytime you're taking the square root of a fraction, I have to take the square root of both sides here to get x by itself. So if I'm taking the square root of a fraction, think about taking the square root of the top and the square root of the bottom separately. So x squared, I'm sorry, we don't have a squared anymore. So x equals plus or minus. Now you want to just take this and simplify it as much as possible. Our answers today are going to be pretty ugly. So 43 doesn't have any perfect square factors, so the 43 is actually going to stay underneath the square root. This negative is going to come out front as an I. So I square roots of 43 all over the square root of 7, because the square root of 7 cannot be simplified either. So this is our answer. But I don't know if you recall when we looked at radicals, actually in Algebra 1, I think we talked about this, having a square root in a denominator, this is considered to be bad form. So you always want to rationalize your denominators. If you end up with a final answer that has a square root in the bottom, what you're going to do is you're going to take that square root and you're going to multiply the fraction by that radical over itself. Because what that's going to do is it's going to get rid of the radical for you. So I'm left with x equals plus or minus, let me move that down a little bit. I still have my I. And then when you're multiplying radicals, the product is going to stay underneath the square root. So I'm going to take 43 times 7. That's going to give me 301 all over. The square root of 7 times the square root of 7, that's going to give me the square root of 49. And the whole reason we do this is because what that's going to do is create a perfect square underneath your square root. And I know that the square root of 49 is just the number 7. So what that's going to do is it's going to get the radical out of the denominator. And then this is your answer. Okay, let's try one more example. 6x squared plus 4 equals negative 108. So again, we have an x here that's being squared. We want to get this by itself. The first thing to do is to subtract 4 from both sides. Those 4s are going to cancel. And negative 108 minus 4 is negative 112. Divide by 6. The 6's are going to cancel. I'm left with x squared equals negative 112 over 6. And hopefully you can see that those two are both even numbers. So you want to simplify as much as possible. So x squared equals 112 divided by 2 is going to give me 56. So this is negative 56. And 6 divided by 2 is going to give me 3. I recommend that you reduce your fractions as much as possible before you take the square root of both sides. It's going to make the numbers smaller and it's going to make it a little bit easier to work with. Take the square root of both sides. Think about the square root of the numerator versus the square root of the denominator. This leaves me with x equals plus or minus. Okay, so 56. I know that 56 has a perfect square in it. And if you can't see it, then go over to the side and make a factor tree. But 56 is actually 4 times 14. So there's a perfect square in it. So when I simplify this numerator, this is going to turn into the square root of 4 gives me 2. I have this negative under my square root, so I'm going to have an I in my answer. And then my 14 can't be simplified any further. So the numerator turns into 2i square roots of 14. The denominator is the square root of 3. That cannot be simplified. So you're almost done. This is bad form because we have a square root in our denominator. So what you want to do is take and multiply top and bottom by whatever that square root is. So we're going to use the square root of 3. So when you're multiplying, you're only going to multiply the radicals together here, the 14 and the 3. The 2i is going to stay. So x equals plus or minus 2i. And then when I multiply 14 and 3, I'm going to get 42. So it's the square root of 42. And then the denominator, the square root of 3 times the square root of 3, that's going to give me just the number 3, because the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is 3. And then when you're doing these, if you would be able to reduce these two numbers here, you would go ahead and do so. The 2 and the 3, those don't reduce. So this is our final answer. Okay, well, there's a few examples for you. Please let me know if you have any questions. Hopefully you took these examples down on a notebook so you have something to refer to. Let me know if you have questions. Thanks.